Hello class, welcome to Digital Electronics class. Hello class. So today we are going to discuss that how we will derive the characteristics table and excitation table of the SR flip-flop from the truth table of the SR flip-flop. So you should remember what we have discussed in the previous class of the SR flip-flop, and we have discussed. So we have done the operation that how does the SR flip-flop work, and we have derived the truth table of the SR flip-flop. Now we will write down this truth table in a new way, and we will try to find out characteristics table and excitation table from the truth table. So now see, this was the truth table which I had written in the previous class. So again I will write down the truth table here. So this is S, this is the input, this is the R, this is the other input. Okay. Then Qn plus 1 I have written here. Qn plus 1 denotes it is the next state. Okay. And Qn plus 1 complement. So instead of Qn I have written Qn and Qn plus 1. So like here I had written Qn minus 1 was the previous state. Okay. So Qn minus 1 was the previous state. So since here I have written Qn plus 1 which is the next state, so definitely what will be the previous state? The previous state will be Qn. Okay. Now when the input was 0 1, okay, when the value of S and R was 0 1, so it was 0 1, okay, it was a reset condition. So the same truth table I have written over here, and in the last condition when the input was 1 1, so it was not used, so I have written a cross mark over here. Okay, so this table is very important and we will be using it to design the characteristics table and the excitation table. So I have made a table over here and it is characteristics table. So basically what is a characteristics table? It is a table which will give you the information about the next output. If the inputs and the present outputs are known, means if you know what is my present output and what is my present input, so you will know what is the value, what will be the value of the next output. Okay, so let us write down the table. So here I will write down Qn. Okay, Qn is what? It is my previous output. Then what are my inputs? My input is S and R, and what I have to find? I have to find my next output. Okay, next value. Okay, so since it is a 3 variable input, so we will write down the truth table. So 1 2 3 4 times 0, then 4 times 1, then 2 times 0, 2 times 1, 2 times 0, sorry 2 times 1, then 0 1 0 1 0 1 0 1. So this is a 3 variable input truth table. Now let us find what will be my output. So for writing this output table, you have to take the reference of this truth table. Okay, so now see, when the value of S is 0 0, okay, when the value of S is 0 and the value of R is 0 0, so then what is the value of my next state? Qn plus 1, the value of next state is the value of the previous state. So what is the value of the previous state over here? It is 0, so I will put here a 0. Okay, now when my input is 0 1, okay, when my input is 0 1, then what is my output? Sorry, so next when my input is 0 1, so when the value of input is 0 1, then what is the value of Qn plus 1? It is 0, so I will put here a 0. Similarly, when the value of S and R is 1 0, so when it is 1 0, my output is 1, so I will write here 1. When it is 1 1, so the value is, we will not consider it. Okay, so now again when the value of SR is 0 0, then what is my next state value? It is Qn, previous value. So what is previous value over here? It is 1. So again I will put here a 1. Again when it is 0 1, so it will be 0. Again when it will be 1 0, so it will be 1. Again when it will be 1 1, so this is invalid state or we don't use it. So this is my characteristics table and it is very easy to write it. Okay, now we will move to the excitation table. So So what is an excitation table? Excitation table gives the information about the excitation. Excitation means the inputs. So you will get to know that what is the input for a particular combination of the output. Okay. So it is a very important table, and it is basically derived from the characteristics table. So you see, the characteristics table is derived from truth table, and the excitation table is derived from the characteristics table. So the most important table is the truth table. If you will know this, you will automatically be deriving all the tables. So let us write down the excitation table. So what are my outputs? So Qn plus 1. So this is my previous state, this is my next state, okay, or present state. This is S and R. So basically this table is about, if you know that what is my present state and what is my next state. If my present state is Qn and my next state will be Qn plus 1. So if you know these values, so what should be the excitation for that, or what should be the input for that? So again, let us write down. So it will be 0, 0, 1, 1, 0, 1, 0, 1. Okay. So now let us see. Here the value of Qn is 0 and Qn plus 1 is 0. So you see this characteristics table, in which places we have got the same combination of Qn and Qn plus 1. So here it is 0 and here also it is 0. Okay. So we will consider this. Okay. Again, here also 0 and here also we have got 0. Okay, Qn and Qn plus 1, 0, 0, and other places no, we are not getting. Okay, so when the value of Qn is 0 and Qn plus 1 is 0, then what was the value of S? It was 0 and the value of R was 0. Again in the second case, it was 0 and it was 1. It means in both the cases the value of S is 0, but the value of R is changing. Okay, so we will write here 0 and we will write here don't care condition. Okay, so this cross is denoting the don't care condition. Okay, so again in the next case, when the combination is 0, 1, so you see where I am getting 0, 1, I am getting 0, 1 over here. Okay, 0, 1, no, we are not getting 0, 1. Okay, so we will consider this. So what is the value of S? It is 1, and what is the value of R? It is 0. So I will write here 1 and 0. So again, when the Qn value is 1 and Qn plus 1 is 0, so 1, 0 I am getting over here. Okay, so I'll put a tick mark over here, and we are not getting any other place. So what is the value of S? It is 0 and it is 1. So okay, so I will simply write here 0 and 1. Now in the last case, 1, 1. So you see where I have got, I'll use another color. Okay, so 1, 1 we are getting over here, and 1, 1 we are getting over here. So two places we are getting. So now see what is the value of S. Here it is 0 and here it is 1. Okay, means the value is changing, and here it is 0 and here also it is 0. So I will put here 0, and since R was changing, so I'll put a don't care condition. Okay, so this is a don't care condition. Okay, I am writing here D so that you will understand. So this is the excitation table of the SR flip-flop. So now we will derive the next important thing, which is known as the characteristics equation. So this will be derived by making a K map, and we will, for that we will consider the characteristics table. So we have input Qn, then we have S, and then we have R. So we will take, this is the K map, so we will take Qn here and S and R over here. Okay, so 0, 0, 0, 1, 1, 1, 1, 0, and here it will be 0 and 1. Okay, so I hope you remember what is a K map and how we reduce a K map. So now let us use this Qn plus 1 in this K map. Okay, so let us put it over here. So here it will be 1. Okay, then we will get, here it will be cross, then here it will be cross, 1, 1. Okay, I hope you know how I am putting this 1 in cross. Okay, so now let us do the mapping. So this will be my first group. Okay, first group, and again this will be my second group by the map folding. So we have two groups. This is group 1 and this is group 2. So now let us write down the equation from this K map. Okay, so we'll write down the characteristic equation. So we are writing the value of Qn plus 1. So when I am reducing the first group, so see the value of Qn in both the cases, it has changed from 0 to 1. Now what is the value of S? It is 1 in both the cells and again 1 in both the cells. So the value of S is constant. So I will write it over here. Then let us see the value of R. So 1, 0. So the value of R has changed. Now let us see the second group. Okay, so for second group the value of Qn is constant because it is 1 in both the cells. Okay, then the value of S has changed, but the value of R is 0, 0 in both the cells. So it will be R complement. So this is my characteristics table, and it is a very characteristics equation which we have derived from the characteristics table, and it is a very important equation because this will help you to find the next state value, because Qn plus 1 denotes the next state. Okay, so hence we have learned here how to find the characteristics table from the truth table, and how to find the excitation table from the characteristics table, then how to find the characteristics equation from the characteristics table. So overall, which is the most important table? The most important table is the truth table. Okay, so in the next class we will discuss another type of flip-flops. Thank you for watching the video. If you have any doubts or any suggestion, you can put it in the comment line, and do keep watching the videos and stay at home, stay safe and fight corona.